All right. Good morning and welcome back. Today we're going to pick up where we left off yesterday, continuing with some story problems. So let's take a look here. It says you are flying a kite. Kite string is 85 feet long. The angle of elevation from you to the kite is 70 degrees. How high is the kite off the ground? Okay. So we have a kite somewhere in the air. And we also have a person, okay, flying this kite. Now the kite is, let's see, it says 85 feet long for our kite string. And we want to know how high it is. So what is that? Okay. Meanwhile, we know this is a right angle formed. It says it is an angle of elevation of 70 degrees. So if we look at my picture here with the hands, angle of elevation is the angle above horizontal. Okay, so 70 degrees, that will go over here, 70. And now we want to label. So if we think about it, this is our hypotenuse. This is our opposite side. So sine, right? SOHCAHTOA, we use sine of 70 over 1 will equal the opposite, x over hypotenuse, so 85. We cross multiply, 1 times x is x. Now remember, anytime we use this, mine was already open, but if you open it, you have to change it into degree mode. Whatever calculator you're using, make sure it's in degree mode. So we go down, go over, hit enter, then I can hit clear. So I just do 85 times the sine of 70, close it, hit enter, and we will get 79.9. If we go to 1 decimal, 79.9, label is the same, feet. Okay, so 79.9 feet above the ground. So, guess my kite, I should have made it a little better. It should have a tail. But anyway. All right, our next one. 2 airports leave an airport. The angle between their flight paths is 40 degrees. An hour later, plane A has traveled 300 miles, while plane B has traveled 200 miles. How far are the planes apart at this time? So for this one, imagine you have an overhead view, okay? And we have our airport here, and plane A takes off in this direction, okay? Meanwhile, plane B goes in this direction. So A, this is plane B, and we don't know how far apart they are. So this is what we're trying to find out. But we do know that this angle in between them is 40 degrees. We also know plane A traveled 300 miles. Meanwhile, plane B only went 200 miles. At this point now, we do have enough information to figure out what this missing side is. We have a side, an angle included, and another side. So SAS, we can use our law of cosines. So if we go back to our formula sheet, law of cosines here to find a missing side. So if you don't have that written down, you can write it down. Now in that example, it was for the missing side A. We are missing side C here, but it's the same approach. So if we think about this missing side as side C, C squared equals, now it equals the other two squared. So 300 squared plus 200 squared minus, and then it's 2 times 300 times 200. You multiply those two together, and then it's times whatever this cosine of our angle that we do have is. So cosine of 40. Okay, once again, make sure you're in degree mode, but we still are. Now, this would tell us what C squared is. So instead, I'm going to take the square root of this whole thing, because then I'll get what C is. So second square root. Now 300, I'll square it, plus 200 squared, okay, minus 2 times 300 times 200 times the cosine of 40. Close that, hit enter, and as you can see, we are going to get C to be 195.1 miles. Okay. And that is how far apart they are. Right here. All right, our next one. This one has kind of a lot of moving parts, so it's not difficult once we get it set up. If we look here, it says a security camera in a bank is mounted on a wall 9 feet above the ground. So right here, this is 9 feet. Okay. Now it says, what angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? So 12 feet from the wall, 6 feet above the floor right here. Now if we think about it, I could draw in this triangle, right angle here. Now 12 feet is the length on that side. If it is, the camera's mounted 9 feet up, we want it to be at 6 feet. 9 minus 6, that'll be a length of 3 there. Now it says what angle of depression? Angle of elevation was above, angle of depression below. Okay. So depression right here, angle of depression, I don't know what it is, but it would be right there. Okay, now likewise, we need to label these. So here is our adjacent, here is our opposite. So O and A, we can use tangent. So tangent of x equals TOA, so O over A, 3 over 12. Now remember, we have to do the inverse tangent to find this. So the inverse tangent of 3 over 12, that will equal x. Now on here, we just hit second tan to say inverse tangent, 3 divided by 12. Close the parenthesis, hit enter, and we will get 14.03. So if we round the nearest tenth, 14.0 would be our degrees. So 14.0 degrees, that's our angle of depression. We should be, in this case, below that. Okay. So we'll do a couple more. We'll do 2 more today. So on this one, an elm tree casts a shadow of 42 feet and is 68 feet tall. So we have some tree here, and it says it's 68 feet tall. We know the shadow, if the sun is up here, it's coming down, the shadow, I know it's maybe tempting to put that over here, but if you think about it, the shadow will actually be on the ground. Okay, so that is 42 feet. And now this one is actually surprisingly a lot like the last one. It says, what is the angle of elevation from the base of the shadow to the top of the tree? Angle of elevation goes up. So what is this? Now it's set up differently, but the last one, remember we had our O and our A. So it's the tangent of x will equal 68 over 42. Okay, all we have to do is take that inverse tangent. So second tangent, 68 divided by 42, close it, hit enter, and we will get x to be 58.3 degrees. All right. We got one more we're going to look at. This one's a little bit more complicated. Has a couple things we're trying to find. So a man and a woman standing 25 feet apart both look up and see a kite in the eastern sky. Okay. So right here we know this distance between the man and the woman is 25 feet. Okay, now they look up and see this kite. The man reports an angle of elevation of 40 degrees. So this is going to be 40 degrees. Meanwhile, the woman's angle of elevation is 60 degrees. But remember, it means above, so this is our 60 degrees right there. So if we think about it, these two angles form a linear pair. Okay, that will be important. Although first, let's figure out what we need to find. So it says, what is the distance from the kite to the woman? So right here, this is what I'm trying to find. What is that distance? Now, in order to do that, let's first use this 60. If that's 60, we know linear pair, this would have to be 120. It's from geometry if you don't remember it. And we have a straight line cut into two parts. Those add up to 180. We got 120. Now we add 120 plus 40. That'll give us 160. You can take that away from 180. Left to 20. That'll go up here. Now the reason that's important is now we have a set of opposite. We have the angle on the opposite side. Once we have that, we can use the law of sine to solve for x here. So I can do the sine of 20 divided by that 25, right, the opposite, equals the sine. Now we're trying to find x. The x will be on the bottom. So opposite of x will be this 40. So the sine of 40. Now we cross multiply. We divide by the sine of 20. And at this point, then, we look what is x. So 25, here, let me put that in parentheses. So 25 times the sine of 40, close it, divided by the sine of 20. And we will get 46.98. So if we round up, we'll get 47.0. So 47 feet. And that goes here. What's the distance from the woman to the kite? Now it says, how high is the kite above the ground? So height, that's going to be right here. But we can use what we just found. I'm going to redraw this triangle now. We already know this was 60 degrees. We just found out this is 47 feet. So we're trying to get to this kite. Now, let's think. We're trying to say how high is it above the ground. So I'll put an X right here. This is our right angle. Now let's label, this is our hypotenuse, this is our opposite, so we're going to use sine. Sine of 60 equals opposite over hypotenuse, so x over 47. Cross multiply, and 47 times sine of 60 will give us our answer. So 47 times the sine of 60 equals 40.7 feet. Sorry, I bumped it. It's not showing up. Let me get that back up. There you go. So 40.7 feet would be how high above the ground it is. All right. Hope you guys have a great day. And if you need anything, definitely let me know. Keep working on the assignment from yesterday, the same 7 problems on It's Learning. If you're stuck, send me an email or a message. Hope you guys have a great day. Bye.